We'll now go through a real-world demo of dynamic airtime scheduling. We're going to use Aerohive in order to demonstrate 3 clients all running at different data rates and really show how dynamic airtime scheduling can affect these clients and improve the overall throughput of this network. So you see that there's 3 clients here transmitting. They are all 3 transmitting at different data rates. The red client has a data rate of 130 megabits per second. The green client has a data rate of 54 megabits per second. And the blue client has a data rate of 18 megabits per second. Now you can see that their actual throughput is the same. And this illustrates that all of the throughput of all the clients gets brought down to the level of the slowest client. And this is because the slowest client is consuming most of the airtime in this situation. And that's because we are using bandwidth-based QoS right now, and this is how 802.11 works. Let's go to the Hive Manager and go ahead and configure this. This is the first page you see when you open up the Hive Manager. It gives you network status, and we then go to configuration, and we're going to change the configuration of our WLAN policy. If I click on the WLAN policy that we're using here, it gives me a bunch of information about the overall network. The WLAN policy is the entire policy set for a specific AP. And you can have multiple WLAN policies that can be used for different locations or different types of configurations within a single location, and contains all of the SSIDs, as you can see, as well as user profiles, which is our role-based configuration system. At the bottom of the screen, there's a bunch of optional settings. One of those is quality of service. And this is one place in which you can assign a bunch of the quality of service capabilities of the Aerohive system. One of those is turning on dynamic airtime scheduling. The beauty of dynamic airtime scheduling is that it just takes a single checkbox to enable. And what this does is it takes all of those quality of service rules that you've already set up and changes them from being bandwidth-based to being airtime-based. It really only takes us one checkbox in order to make that happen. And it will carry over all the other policies that have been set up already for bandwidth to airtime. So I click that button, I save the WLAN policy, and then all I have to do is push the configuration to the access point. This can be done in service, so this is an in-service configuration update, and therefore the AP does not need to reboot, and it can just change functionality right away. So I click on the one that I want to update. I update configuration. I'm going to select Delta upload, which basically will just send the new configuration to that AP. Click next, and it is uploaded. This will give you the status. It should just take a second here to get up and going. Now we go to Wave Dynamics, and you can immediately see the response within the access point. You can see that within just seconds, we have greatly changed the throughput. Now you'll see that fast client, again that red client that has a data rate of 130 megabits, is now getting on the order of 30 megabits per second throughput, and as opposed to the 6 to 8 megabits it was getting before. The green client, which has a data rate of 54 megabits, is now getting about 12 megabits per second throughput. And the slowest client, which has a data rate of 18 megabit, is getting about 4 megabits per second throughput. So while the slower client actually gets less airtime and therefore goes slower, the trade-off of reducing the bandwidth of that slowest client by about 1 megabit per second or 2 megabits per second has a huge impact on the rest of the network. Now, what ends up happening in the real-world scenario, the fast clients will get off the network, therefore freeing it up for the slower clients to finish transmitting. So in effect, even though this shows the slow client being dropped in performance just a little bit, it overall speeds up the entire network. And even that slow client can see a performance improvement because the fast clients get on and off the network faster, freeing up the airtime for the slower client.